Assalamualaikum. My name is Nur Azali bin John. So I would like to explain about the source-free RC circuit. Okay. A first-order circuit is characterized by a first-order differential equation. So, by applying Kirchhoff law to purely resistive circuit result in algebraic equation. Apply the law to RC circuit, produce differential equation. By using this formula, IR is depend on Ohm's law and IC is depend on capacitance law. Next, the natural response of the circuit refer to the behavior in terms of voltage and current of the circuit itself, with no external source and excitation. Time constant of a circuit is the time required for the response to decay by a factor of 1/e or 36.8% of its initial value. Decay faster for small and slower for large. The key to working with a source-free RC circuit is finding by this equation. First, the initial voltage equal to V across the capacitor. Second, the time constant equal to RC.
Hi, Assalamualaikum. So today I will show about source-free RC circuit calculation. For the first step of t is smaller than 0, the capacitor will be in condition of open circuit. Then, apply voltage divider rule in the circuit and we'll get the answer. For voltage, capacitor is 15 volt. For information, when t is equal to 0, it is also equal to t smaller than 0. So the Vc is equal to 15 volt. Next situation is t is bigger than 0. So to find tau, it is equal to R times C. So we have to find the R total first. After that, we use R total and times it with 20 microfarad and we'll get the answer. By using this information, we have to find the voltage time and the answer is 15 exponent negative 5t, and we can find the answer of energy stored in the capacitor. That's all for source-free RC circuit calculation. Thank you.
For circuit simulation, we need 1 ohm, 3 ohms, 9 ohms resistor, 20 millifarad capacitor, 1 single switch, DC power supply, oscilloscope and 1 multimeter connect to the capacitor to know the charging and discharging process. Make sure all the connection is correct. Then we will run the circuit. During charging process, we will close the switch and capacitor will charging to 15 ohms. The graph in oscilloscope will increase. And when we open the switch, the circuit become open circuit and the graph will become decrease. This is what we call the stage of this charging process. And that's all for circuit simulation.
Okay, hello guys. Today I would like to show you how to solve question about source-free RC circuit. So the question asks us to determine VC, Vx, IO. So assume VC equal to 50 volt. So first of all, we need to settle this down. This is a parallel. So R total for this part, we need to 15 times 3 over 15 plus 3 equal to 2.5. This is for this part only. So we need to combine this to this part. So we get this. So 2.5 with 10 is series. So series, we just need to add. So R total for this part is 2.5 plus 10 equal to 12.5. Okay. So after that, after we got the R total, we can find the torque. So what is the formula of torque. So torque equal to RC. We know that R is 12.5 and C, the capacitance, is 6. So just times 12.5 times 6 equal to 75. So next we can find the VC. So VC is formula equal to V naught exponent negative T over torque. So where we get this V naught? The V naught is, for the question, as need us to assume the VC equal to 50. Okay, so this is 50 exponent negative over 75. So 50 exponent negative 0.03. After that, we can find the Vx. We can find the Vx using the voltage divider law. So we get the 2.5 over 12.5 times the VC 50, and we get 10 V. After that, we can find the I/O using Ohm's law. That means equal to V over R. So we get the V50 and then R 12.5. So we get the 4. So for the I0, we can get negative 4 exponent negative 0.013. Why this is negative? Because capacitance flow from negative to positive. Thank you.
The conclusion, the analysis is applicable to any circuit that can be simplified to an equivalent circuit comprising a resistor and a single energy storage element, capacitor or inductor. When they analyze RC, bear in mind that capacitor is an open circuit at steady state DC condition while inductor is a short circuit. The general form of the natural response is by this equation. The time constant is the time required for a response to decay to 1 over E, its initial value. For RC circuit, time constant equal to RC for circuit. Thank you.